this section we're going to talk about polynomial division, and to do that we're going to first start talking about just basic long division with numbers, because it's the same algorithm, it's the same process. So let's recall how division works. Let's look at something like 1728, and we're going to divide that by 7. Okay, so what happens with long division is, well, we form groups. There's two sort of division processes. There's how many groups or how many in each group. So if I want to think about this, I'm gonna think about one of those two scenarios, and the one that works best for explaining things is the how many groups. So we're going to think about 1,728 things, let's just say pieces of candy, and we're going to put them into groups of size 7, and we want to know how many groups of 7 pieces of candy we can form. And then we also want to know how many are left over, how many would have to be split up still at the end after I form full groups of size 7. So the first thing we do, and this might be a little bit different, let me slide this down a little bit because I want some more room up top. So I'm going to take 7 into 1,728. So I can form there's two 7s that go into 17. That's how we usually do this. But what that means is, because it's in this position, there's really 200 groups of 7 pieces of candy that I can form right away. And that means that I used up the 14. The 2 times the 7 becomes the 14, but I'm going to put on these extra zeros, which we usually don't write when we write out the algorithm. Okay, so I have formed 200 groups of 7 pieces of candy. I have used up 1,400 pieces of candy, so I don't have to put those into groups anymore. I'm going to take them away from my original 1,728 pieces of candy, and I have 328 pieces of candy left over that I haven't formed into groups. I have 200 groups of 7 pieces of candy, and I still have to keep doing this. I still have to put groups together. Okay, I can still form, the next thing I would have written down would have been a 4 in this spot. I'm going to put it up above there because I've yet to form that group, and I get 28 pieces of candy if I form 4 groups of 7, but I've got that extra 0 in there, so I actually use 280 pieces of candy to form 40 groups of 7 pieces. And we're going to subtract that off again. This is just our standard algorithm. I'm left with 48 pieces of candy is what I have yet to form into groups. And it's almost 7 groups of 7, but it's not quite. So I have 6 groups of 7 pieces of candy left over to form, and I have 42 pieces of candy to make those 6 groups. If I subtract off, I have 6 groups of candy, or 6 pieces of candy that haven't been formed into groups. These things get added together, and I have 246 pieces of candy, or groups of candy, with a remainder of 6 pieces. Okay, so what this means, I'm going to write a number sentence down with what this means. It says that 1,728 is equal to 246 times 7 plus 6. There are 246 groups of 7 pieces of candy and 6 pieces of candy left over. Okay, that gives me all of these things. So let's write this down. This is the total, and it's equal to the quotient, the groups, times the divisor plus the remainder. And this is going to be useful for us when we're doing polynomial division, because we're not going to write down just that we have a remainder or anything. We're going to kind of write it in this form, but I'm going to switch it up just slightly. Divisor and remainder. Okay, so the other way that we could write this is I could write it as 1,728 divided by 7 is equal to 246 plus 6 divided by 7. Right. These 6 pieces still needed to be divided by 7. Well, that means that there's 6/7 of a piece. There's 6/7 of a group left to form. Okay, this division is the one that we were performing, and it's equal to this quotient plus the remainder divided by the divisor, right? So the total divided by the divisor is equal to the quotient plus the remainder divided by the divisor. And this is how we're going to write out the answers, the solutions to our long division problems with polynomials. Let's talk our way through one of those using the same ideas. Okay, so let's look at something like 3xyz over xy. Something very basic to start with. We've already done these types of divisions, right? I can just cancel. I get 3z. There's no remainder. It went into there evenly. Okay, so this basic division is going to be key to doing bigger polynomial division. So let's look at something like, say, 2a cubed plus 13a squared plus 11a minus 6, and we're going to divide that by, we're going to divide it by 2a plus 3. Okay, we still have to form groups, and we're going to add them up at the end. And up here, we sort of added them up vertically, right? This was a vertical addition. Here, we're going to do it in sort of place value. I've got place value based sort of on the degree of the variable. I've got degree 3, degree 2, degree 1, degree 0. We're going to add up things based on that place value, and I'm just going to base my division on the biggest term here, right? So I'm going to divide 2a cubed by 2a, and just like up here, things cancel, right? I've got the 2's cancel, one of the a's cancels, I get a squared left. So I'm going to write an a squared into the position that's right above the 2a cubed. And now, just like with this, what did we do? We multiplied the number of groups that we had times the size of each group, and we took that away from the total. Okay, so essentially what this is saying is I formed a squared groups of this size, and I'll have to take that away from the total. So I'm going to multiply a squared times 2a plus 3, and I'll get 2a cubed plus 3a squared. And what happens is I take away exactly that first term every time is what should happen. So I have this 2a cubed plus the 3a squared. Those are the things that I've already put into groups, and I'm going to take those away from my total. This was my total. And so these guys, these two things right here should always be the same. Like in the next step, whatever I have here and whatever I have here and subtract off, that should be the same. So for now, I've got the 2a cubed. I get 0 right there because I'm taking it away. I've got 13a squared, and I'm taking away 3a squared, so I should have 10a squared left, plus 11a minus 6. Those things are still left. I don't have any a cubes left because I put all the a cubes into groups already. Okay, same idea. I'm going to take the 2a. I'm going to see how many times it goes into 10a squared. So I got 10a squared over 2a. That's just going to be 5a. I'm going to add those groups because those are the new groups that I formed up here. And I get 10a squared times, so this was a 3, so I have the 10a squared from these two guys, and then the 3 is going to give me more, 15a. And I need to take that stuff away. Like I said, this is going to go to 0. I'm going to take away 15a from 11a. That's going to give me a negative 4a and a minus 6 left over, right? Okay, how many times does 2a go into negative 4a? Negative 4a divided by 2a. The a's cancel. Negative 4 over negative 2 is negative 2 times. So I'm going to add a negative 2 up here, which just means I'm going to subtract a 2. That goes over the 11a. And then I multiply the negative 2 times the 2a plus 3, and I get negative 4a, which is right because I know those things should disappear. And the negative 2 times the positive 3 gives me a negative 6. Okay. When I take that stuff away, negative 4a minus a negative 4a is 0. Negative 6 minus a negative 6 is also 0. So there is no remainder. No remainder in this one. So let's write this out. What this says is that 2a plus 3, if I divided 2a cubed plus 13a squared plus 11a minus 6 by 2a plus 3, I end up with a squared plus 5a minus 2. Okay, so that's the result of my long division of that polynomial. Okay, let's see another one. There's some issues with this where maybe a term is missing, but let's do a smaller one here. Let's do x squared minus 10x plus 21. We're going to divide it by x minus 7. Okay. One of the things you could do is you could think about factoring the top and then seeing if anything canceled, but if there's a remainder at all, then that doesn't work so well. So let's try this one again real quick, and then in the next video we're going to see some unusual things that might happen sometimes. So I got x minus 7, and it's going to go into x squared minus 10x plus 21. So I'm going to take x squared, I'm going to divide it by x, I'm going to get an x there. Right? I multiply x because I've got x groups of x minus 7 things. I get x squared minus 7x things that I've put into groups, so I will take those away from the total that I'm putting into groups. The x squared minus the x squared goes to 0. Negative 10x minus a negative 7x leaves me with a negative 3x. Okay, and then I have a negative 3 up here because negative 3x divided by x is left with negative 3. We multiply things out. I got this plus 21 that slides down. Multiply things out, negative 3x. And then I get a plus 21 because negative 3 times negative 7 is plus 21. I take those away. I get 0. I have a remainder of 0. What this says is this is equal to x minus 3. Okay. All right. In the next video, we'll see what happens when you have a remainder, and we'll see what happens when your polynomial might have some omitted terms.